Section 3.4, Assignment 2, number 28. So here we have a rational function with a radical in the denominator. Now, I could take a couple of different approaches to find the derivative of this function. The first that comes to mind is, of course, I can do quotient rule, which a lot of times people want to avoid because it's the more complex of the two main differentiation rules, product rule and quotient rule. I could use a product rule if I, instead of writing this as radical x to the fourth plus 4, if I wrote it instead, for example, as x times x to the fourth plus 4 to the negative 1/2. So I could technically use the product rule just by rewriting it. However, I'm actually going to use the quotient rule in this case, and mainly because of this denominator here. Now we know that when you find the derivative of a rational function like this one, the quotient rule tells us that what we do is we take the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator over g squared. Now that's the thing that's making me want to use the quotient rule. Notice that when we use the quotient rule, we take the denominator and square it. Well, our denominator just so happens to be a square root. So to me, it makes sense to use the quotient rule because this is going to cancel out this to the second power is going to cancel out this square root, and it's going to help me with my simplification. So I am going to use the quotient rule. So let's get started. So in order to find the derivative of our function, we follow this recipe here. So we take the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. Now this is what I was talking about here. So if our denominator is square root x to the fourth plus 4 and we're squaring it, then what we end up with is just x to the fourth plus 4. All right, so now let's continue to resolve the numerator. So the derivative of x is just 1 times x to the fourth plus 4 to the 1/2 minus x times the derivative of the denominator. Notice that we are going to have to use the chain rule here because we have x to the fourth plus 4 raised to the 1/2 power. So to find the derivative of this, first we take the exponent and we bring it to the front as a coefficient times x to the fourth plus 4 to the 1/2 minus 1 is negative 1/2. So to the negative 1/2 power times the derivative of the inside. Remember, when we use the chain rule, not only do we have to find the derivative of the overall thing, that's 1/2 x to the fourth plus 4 to the negative 1/2, but we have to multiply by the derivative of the inside. Well, what's the derivative of x to the fourth plus 4? Well, that's going to be 4x to the third. All right, so we're getting there. So now let's just continue to simplify. So 1 times this is just going to be itself. Now let's multiply all of the different coefficients. So x times 1/2 times 4x cubed. So x times x cubed is x to the fourth, and 4 times 1/2 is just 2. So we're going to end up with 2 times x to the fourth times x to the fourth plus 4 to the negative 1/2 all over x to the fourth plus 4. Now, what I want to do next is I want to get rid of this negative exponent. So what I'm going to do is I'm going to put brackets around the entire thing to show that I'm about to multiply this entire thing by something. Well, what am I going to multiply by? Well, I'm going to multiply by something over itself. And the reason why I have to do that is because basically multiplying by something over itself is essentially multiplying by 1, which does not change the function overall. Now we just got to decide, what are we going to multiply by? Well, to get rid of the x to the 4th plus 4 to the negative 1/2, I'm going to have to multiply top and bottom by x to the 4th plus 4 to the positive 1/2 over itself. All right, so now what I need to do is I need to distribute this into the numerator. So what I'm going to do is I'm going to multiply x to the 4th plus 4 to the 1/2 times each thing in the numerator. So let's see what happens. So x to the 4th plus 4 to the 1/2 times x to the 4th plus 4 to the 1/2 is just x to the 4th plus 4. Because when we use the basic rules of exponents, remember back to maybe algebra 2 trig, when we multiply two powers with the same base, we simply add their exponents, and 1/2 times 1/2 is really just 1. Now what happens when I multiply x to the 4th plus 4 to the 1/2 times this entire thing? Well, notice again, we're going to add these two exponents. So negative 1/2 times plus 1/2 is 0. So we're going to end up with 2x to the 4th times x to the 4th plus 4 to the 0 power, which is just 1, all over x to the 4th plus 4 times x to the 4th plus 4 to the 1/2. Let's not forget to also multiply the denominator by this factor. We're almost done. Hang in there. So now let's just simplify the numerator and the denominator for one last time. So here we have x to the 4th plus 4 to the 1 power, which is just x to the 4th plus 4, minus 2x to the 4th times 1, which is just 2x to the 4th. So x to the 4th minus 2x to the 4th, that's going to be minus x to the 4th plus 4 in the numerator. And in the denominator, we have x to the 4th plus 4 to the 1st power times x to the 4th plus 4 to the 1/2. So again, whenever we multiply two powers with the same base, we simply add the exponents. Well, what's 1 plus 1/2? That's going to be x to the 4th plus 4 to the 3/2 power. And that's pretty much all we can do with that problem.